everyone. Okay, so your lesson today will be on for 5.1 worksheet. So if you go to these notes, 5.1, the worksheet's right after it. The worksheet will be very similar or the same type problems that you see right here. Over the today and tomorrow, you're going to be working on this worksheet, and then S16 and 17, if you haven't done S1, which I know a lot of you have, I'll work on that as well. Okay, so first thing that we're going to do, a function whose graph forms a straight line is called a linear function. So when we have a linear function for this first part, which is going to be exactly the same on your worksheet, is that there's two questions it's going to ask. Is it a function? Is it a linear function? So first you have to determine if it's a function. So remember, for a function, you have every input has exactly one output. And the way we do that is a vertical line test. So as long as a vertical line only intercepts the graph in one spot, which it does in this case, yes, it's a function. So that's the first question, just basic question, is it a function? Then the second question, is it a linear function? And for this is a line, so yes, it is. The next one, if you look at this, even though it's a line, it wouldn't pass the vertical line test, so it's not a function. And if it's not a function, even though it's a line, it can't be a linear function because it has to be both a line and a function. So is it a linear function? The answer is no. Okay, next one, vertical line test doesn't pass, so it's not a function, and also it's curved, and also not a function, so it's not a linear function. For number 4, passes the vertical line test, so yes, it's a function, and it's also a line, so yes, it is a linear function. Here's an example where if you look vertical line test, it is a function, but that's obviously not a line. We call that a parabola, so it's not a linear function. And then the last one would be yes, it's a function, and yes, it's a line. Okay, so the next step is looking at tables and determining if they're a linear equation or function or not. You can sometimes identify a linear function by looking at a table or a list of ordered pairs. A corresponding change in x corresponds to, I'm sorry, not corresponding, a constant change in x for a linear function corresponds to a constant change in y. So as long as your x's go up by the same amount and then your y's go up or down by the same amount, then it is a table that represents a linear equation, because you know slope is rise over run, it's consistent, goes up the same over the same each time. So what you do is you look at the change from one x to the next, and typically they're going to give you x values that change the same. So if I go from -2 to 1, that goes up 1. If I go from -1 to 0, that's going up 1, and then 0 to 1 goes up 1, and then 1 to 2 goes up 1. So all the x's go up the same amount. Now we want to see how the y's are changing. So the y's go from 9 to 5, which is down 4, from 1 to 4, which is down 4, 1 to -3 is down 4, and -3 to -7 is down 4. So that means every time that the x changes by 1, the y changes by 4 as well. And that is a linear function. So the answer would be yes. Okay, so let's look at this one. The x's are going up by 1. I'm not going to write in the interest of time, but they're going up by 1 the whole time. The y's right here, this goes down by 3, and then it's going down by 1. So right off the bat, that change is not the same. It is no. Now, if those were the same, you would keep going until you get different ones, and then you'd say no, but if you get them all the same, then you'd say yes. Okay, next one. Now, instead of just graphing right off the bat, we have to solve for y first. So we've done this before, but before we do our input-output table, we have to solve for y. So you circle the variable you're trying to get by itself, which is y, and you look at that equation and go, okay, I have to get x to the other side. Well, if it's a positive x, I have to subtract x. So I have y equals 3 and x are not like terms, so you could either write it as 3 minus x, or you could write it as y equals negative x plus 3. Either one you can write out as. And then you just want to pick some nice, neat x values. What are some nice, neat x values? 0, 1, and 2. And then you go ahead and plug in. Now, this is just the same as the input-output table. It just doesn't have all the same information as we typically have, but it's still just an input-output table all the same. So if I plug 0 in for x, we have 3. If I plug 1 in for x, negative 1 plus 3 would be 2. And then from here, you can plug in 2 again, but you see, as we're going up by 1, we're going down by 1 for y, so we go down by 1 again. And then we graph those 0, 3, 1, 2, 2, 1, and then we get our line from there. 2, same thing. It's just going to require a little more work in terms of solving. Again, you circle your y, and you go, okay, I have to get rid of the 2x, and I have to get rid of the 3. If I want to get rid of the 2x, I have to subtract 2x to that side. And now I have 3y equals negative 2x plus 3. And again, you could write the x term second. But I hope we're going to get good at starting to get the x term first, as we're trying to get in that y equals mx plus b. We're working towards that. Now we have to solve for y by dividing by 3. We divide by 3 on all terms. Now you have y equals that fraction, negative 2/3 doesn't reduce, so we just rewrite it, and then the x after it. But that 3 over 3 reduces to 1. So now we have y equals negative 2/3 x plus 1. And you look at that and you go, okay, I want to pick my input values. I want to pick input values that work nicely. Well, because we have that fraction, that complicates things a little bit. Well, first off, if I plug in 0, that's really easy. Always use 0. It's super easy because then the x term goes away and you're just left with the constant. And then you look at it and you go, well, if I have a denominator of 3, if I have 3 over 3 or 6 over 3 or 9 over 3, then it will reduce nice and neat. So I'm going to pick multiples of 3. And I decided to pick 3 and 6. So now I'll go ahead and do one of them explicitly. If I plug in 3 in for x, now these 3's reduce because that's 3 over 3, which is 1. So that would be negative 2 plus 1, which is negative 1. Coming back up to here, or same thing, I forgot to plug in 0. Sorry, if I plug in 0, the negative 2/3 goes away, and I'm left with 1. Now, you could plug the 6 in, reduce, and simplify, but again, since we're going up by 3 each time, and this is a linear function, then we can continue the pattern. We're going down by 2. We can go down by 2 again from that, and we get that point. So 0, 1, 3, negative 1, and then 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, negative 3, and we graph the line. Okay, coming down here, I think you have a couple problems like this on your worksheet. In a coordinate plane, the graph of a horizontal line is x, y equals some value. Y equals a, for instance. So if this is like the y value of a right there, then the horizontal line. Why is that? No pun intended. Because the graph can't go, this line does not go up and down at all. It only changes x. So y remains the same. And then over here, on the second part, in the coordinate plane, the graph of the vertical line is always x equals a. So let's say this is an x value of a. Vertical line is x equals a. Because if x is always the same, you can't move left and right. You can only move up and down. The x value stays the same. This is very confusing for students, understandably, because we think x-axis is horizontal, therefore x equals the equation of a horizontal line is x equals, when it isn't. It's y equals. The x-axis, like for instance right here, is a horizontal line, but the equation of that is y equals 0. And then same for the y-axis. The y-axis equation is x equals 0. Okay, so how do we do that in input-output table? Well, if we look at this, y equals 3. That means no matter what, whatever points we have y equals 3. Y has to be 3. X, we can choose any x values we want because that has no restrictions. That's just whatever. It's the only restriction on this equation is that y equals 3. So now we graph those 0, 3, 1, 3, 2, 3, and then if we continue, we see we get a horizontal line. Again, why it is that y equals a number is a horizontal line. For number 2, now we pick our x values. X value has to be 4, and now we pick y value 0, 1, 2. Of course, you can pick anything else. If I do that, I get 1, 2, 3, 4, 0, 4, 1, 4, 2, and I get a vertical line. So that's the worksheet for 5-1. Okay. And then you're also going to do over the next 2 days S16 and S17. Okay, so S16, I'm going to go through as many as I can here. It says here that function A and B are linear functions. The slope of, and you have to choose. The slope of function A is greater than the slope of function B. Well, first off, the slope, y equals mx plus b, is going to be true for, you're not only going to need to know the slope, you're also going to have to know the y-intercept. This right here is your slope of the line because that's how much x is increasing by. This is your y-intercept because y-intercept x equals 0. And if you plug 0 in for x, you're left with just b because the mx part goes away. That's going to be helpful for all of these, okay? So let's look at our slope here. Slope is rise over run, how much the y's change relative to the x's. So if we look at the x's go up by 3 here, okay? And here, the y's are going up by 15. So the change in y is 15, and the change in x is 3. And if I do 15 divided by 3, that gives you a slope of 5. That's how you can find the slope off of a table. You do just a change in y's, and you could do it with any of them. I could have done it with -10 and 25, and I could have done that with -1. I would have gotten the same thing. So the slope of A is 5, and the slope of B, which is right there, is 3. So A has a greater slope than B. Okay. Now we want to look at it in terms of the table. Again, change in x, it's going up by 5. Change in y, it's going up by 20. Actually, first I got to look at the question and see what the question's asking. Slope, yes, is asking for slope. Okay. So now what I want to do to find the slope here is I get 2 points. Any 2 points, I could have done those, that one, etc. So I'm going to go from here to there. The rise, how far I rise to go from there to there, is 2. Divided by the run, I go 1. And note it's a positive 2 because I went up 2, and it's a positive 1, so I went up 1. So the slope is rise over run, which is 2. So the slope of B is 2. The slope over here, remember, was, sorry, I didn't do it earlier. The x was a change in 5, and the y was a change in 20. So I do y x 20 divided by 5 gives us a slope of 4. So A has a greater slope than B. Oops, I didn't click it. Sorry. There we go. Okay. Okay, so next one. Now, again, they're not just going to ask on slope. They're also going to ask on y-intercept. Okay, so I'll erase this really quick. Okay, so, and I'll rewrite that y equals mx plus b. So you look here, which statement is true? The y-intercept of A is greater than the y-intercept of function B, or the other way around. So again, if we have y equals mx plus b, m is our slope, and b is our y-intercept, where it crosses the y-axis. So this time we're comparing the y-intercept. So I look here, that's crossing right there. So my y-intercept, or b, is equal to 5. Now, what do you notice about the x value at that point? 0, 5. The x value is 0. So when I look at this table, I want to look at what would the y value be when x is 0. Well, it doesn't list 0 here. But if I look here, if I write 0 here, I look at the pattern. This is going down. This is going down. So if I'm at -1, I'm going to be going down from -1 to get to the y value of the y-intercept. It's going to be 0, something like -3, something like that. Something less than -1. Okay? And I look at that and I go, okay, this y-intercept is 5. This one's -3. Well, which one's greater? The first one's greater. So A is going to be our answer. Okay? Now, because we're not creating the function yet, we're going to have to do some estimates here. Okay, this is another slope problem. I'm going to pause it for a second. Okay, this is the last one I wanted to get to for S16. So we look here, and again, y equals mx plus b. Again, m is your slope, b is your y-intercept. And we'll talk about why y equals mx plus b. I talked about very briefly, but we'll talk more about why that is. Okay, so we look over here, we have y equals 3x, and there's nothing after it, so it's 3x plus 0. So our y-intercept is 0. So now we look over here and we go, okay, well, what about, what's our y-intercept here? Well, we're just going to have to, like, estimate. Well, where is x 0? Where x is 0, somewhere between 4 and -8. So if I have 4 and -8 on a number line, if I think about 4 and -8 on a number line, 0 is going to be a little closer to the 4. So our y-intercept is going to be a little closer to the 1, but it's somewhere between -11 and 1, a little closer to 1. Not a ton closer, right? It's not like right up against 4, but a little closer to that. So where x equals 0, y is going to be less than 1. Well, do you think it's going to be less than 0? Yeah, I think so. Again, it's an estimate. So is it less than 0? Yeah. So the y-intercept for A is greater than B. Okay. So that for those, you're just going to have to guess on, do your best. It's an educated guess. And, you know, if you don't get all the way through them, that's fine. Just do your best with them. And then we'll talk some more on Monday regarding that. Okay, the next one is going to be S17, which is right in standard form. This one's really not that bad. So if we have, this is standard form. ax plus by equals c. So like 2x plus 4y equals 7. Right? Like an example would be 2x plus 4y equals 7 would be example of standard form. Now, a has to be positive in order to get the correct standard form. Okay? So let's look at this. So if I have this, I have y equals, that's y by itself. Well, I want x on the same side. So I need to subtract over the x term. So I have negative x plus y equals 3 because these two cancel. Note, when I move that x term over, nothing else changes. Just the negative, the negative 9x moves to the left. The y and the 3 stay the same, and I want the negative 9x. Now remember, I said that a has to be positive. Well, right now it's negative. So I'm just going to rewrite it so you can clarity for you to see. Okay? If this is negative, I need to make that positive. So if I make that positive, that's really like dividing by negative 1. I have to make all the terms. I have to divide all the terms by negative 1. So my answer is 9x minus y equals negative 3. Awesome. All right. So same thing again. Get into standard form. Again, you have to get the x to the other side. So if I have this, I have to add over 8x to this side. Again, you can't combine those because they're not like terms, so you just write them next to each other. Equals negative 1. And then I go ahead and plug in. So I have 8x plus y equals negative 1 plus y equals negative 1. And same thing over and over. Okay, so pretty much a lot of these are going to be the same structure. I don't think they're much different. So I'm going to move that 10x over, so I'm going to subtract 10x, and that will give us negative 10x plus y equals negative 6. Once again, to divide by a negative to get that first term positive, and then that will give us, each term has to switch signs. Whatever sign it is, you just switch it. If it's negative, you make it positive. If it's positive, you make it negative. Y equals 6. Hit enter. Boom. Okay, so that's, again, worksheet 5.1, S16, S17, and I will see you all on Monday.